In this video, we are going to talk about a strategy for solving problems 5 through, I believe it's 9. Yeah, 5 through 9. We're not going to actually solve the problems, but I'm going to get you set up to either choose to factor, if possible, or use the quadratic formula. The quadratic formula will always work, albeit sometimes plugging in and simplifying can be a daunting task, but that strategy will always work for solving a quadratic equation. So when I look at 5, first off, I see a's, and I think you don't have to do this, but I think replacing all the a's with x's is beneficial just because the quadratic equation has a in it, but that's entirely your choice. But dealing with all these decimals makes the computation a little bit more challenging, and we could clear those decimals by, in this case, multiplying both sides by 100. Let's see that and set it up. All right, so here I have number 5 written down. It's totally optional, but I think replacing those a's with x's, especially if you end up using the quadratic equation to solve this, is beneficial. And now what we're going to do is we are going to clear these decimals by multiplying by a power of 10. In this case, if I multiply both sides by 10, I still would have a decimal. But if I multiply both sides, maybe we'll get a different color for more contrast. If I multiply both sides by 100, you see that we're going to be clearing these decimals. Feel free to use a calculator. 100, oh, and I said I was going to replace all these a's with x's, and then I didn't. I apologize. That's entirely optional. Okay, so if I multiply both sides by 100, you see that I now have 100th times 100, which is just 1 x squared, minus 200ths times 100, which is 2x, minus 400ths times 100, which is just 4, which equals 0. And you could go ahead and try to factor or use the quadratic equation. So what we've done here is we have cleared the fractions. All right, and so if you were going to go ahead and factor, you know quite a bit of the story already. X times x is x squared. You're looking for two things that multiply together to give you -4 and add up to -2. And if you're unable to do that, you can use your quadratic equation, and here your a is 1, your b is -2, and your c is -4. Okay, so that's the setup for 5. Let's look at the setup for 6 now. All right, so here is question number 6. We're asked to solve either by factoring or using the quadratic formula. On this one, I don't think it's worth replacing the y's with x's. The quadratic formula has a, b, and c in it, and that's why on this problem 5, and again, it's entirely optional, I think it can be a little confusing to have a show up here and then also be the coefficient of the squared term. So that's why I think replacing a's with x's is nice here. But here I think we're totally fine. Now you're free to go ahead and try to factor this or use the quadratic formula, with a being a 24th, b being positive a fourth, and c being a third. But instead, it'll be a lot easier if we clear our fractions by multiplying both sides of the equation by my least common multiple of 24, 4, and 3, which in this case is 24. That'll go ahead and clear our fractions and make the arithmetic a heck of a lot easier. So it's worth doing. And here we have it. 24 times a 24th is 1, so we've got just 1 y squared. 24 times a quarter, and maybe we even write that for a second, but you can go ahead and simplify it because dd division by my denominator, 24 divided by 4 is 6. And then 24 times a third, multiply by those fractions straight across, but you can go ahead and simplify those right away because 24 divided by 3, that's divisible. We're going to do that on the next line. And 24 times 0 is just 0. So we've got, and maybe just for the heck of it, we've got 1 y squared. You can just write y squared. 24 divided by 4 is 6y. 24 divided by 3 is 8 equals 0. And now you can go ahead and play the factoring game because my leading coefficient is 1. Try to find two numbers that multiply together to give me 8 and add up to 6. And if you can't find those numbers, or if you just want to practice the quadratic equation, go ahead and use the quadratic equation on this. A is 1, B is positive 6, and C is positive 8. Notice that that's a lot nicer than dealing with A being the fraction of a 24th, B being the fraction of a quarter, and C being the fraction of a third. And I'll leave it to you to go ahead and finish that. Let's go ahead and look at number 7 now and do the setup. All right, so here is number 7. So number 7 is right here. And again, A shows up in the quadratic formula. And especially on this one, the answer key has these spaces, like on this one, where you're entering in the real number plus some amount of I plus a square root divided by some number. And so I know that this one's not going to be factorable. So particularly with this guy, I think it's because I know I'm going to have to use the quadratic formula on it. It's not ready to use it yet, but since I know I have to use it, I think it's beneficial to replace all the A's here with X's. Just because the quadratic equation has A, B, and C in it, and it can be a little confusing. So I'm just going to do that. All right, and step 1 is to set this guy equal to 0. Perhaps before we do that, we want to clear our fractions. Here I have a denominator of 5 and a denominator of 1. 4 is 4 over 1. And here I have a denominator of 3. If I skip count by 1, 3, and 5, the first number that they have in common is 15. So if I multiply both sides by 15, I can go ahead and clear my fractions. And if you want 15 is 15 over 1, that's fine. What I do to one side, I do to the other, and I'm choosing to multiply both sides by 15 to clear these fractions. Notice that this is very similar to the choice that we made here to clear fractions, and very similar to the choice we made here to go ahead and in fact I even wrote clear fractions. Decimals are fractions. Here we are is clearing those. I think this feels more comfortable. decimals. All right, so let's go ahead and do that. Using my distributive property here, because I have 1, 2 terms. 15x squared divided by 5 is 15 divided by 5, which is 3, times x squared, plus 15 times 4, which is 60, is equal to 15 times 4x divided by 3. There's a secret times 1 here. 15 divided by 3 is 5. And 5 times 4x is 20x. All right. If you need to put in more steps between here and here, that's perfectly fine. I did talk you through it though. We're now going to go ahead and set this guy equal to 0. Right? We're not going to lose track of our equal sign. I'm going to go ahead and subtract 20x from both sides. There is no x term on the left-hand side, so I'm just going to give myself a little bit of space. (3x squared minus 2x plus 60 is what's on the left-hand side. And on the right side now is our 0. Dealing with a being 3 minus 2 and 60 is most likely preferable than here. If I didn't set this equal to 0 first, but dealing with these fractions, like if I didn't clear these fractions, a would be 1/5, b would be minus 4/3, and c would be 4. In my mind, I was just setting that equal to 0. And having fractions showing up in the quadratic formula vastly complicates things. And so this step of clearing fractions by multiplying both sides by the least common multiple of each of the denominators just makes my life a little bit more simple. Let's look at number 8 and set that one up as well. Oh, your teacher is tired. What I do to one side, I do to the other. What did I do? I subtracted 20x on the right-hand side, and I subtracted 2x on the left-hand side. Whoops. I'm so glad I caught that. So we have 3x squared minus 20x, not 2, minus 20x plus 60 is equal to 0. And then I'm going to leave that to you. Okay, so now let's go ahead and set up 8. All right, so you are finishing 7 on your own. We're just setting it up. Now we're going to set up 8 as well. We're going to approach this the same way. We're going to clear these fractions. If you want 9 is 9 over 1. If I multiply both sides of this equation, by x squared, I'll clear my fractions. And I've been doing that by just writing the parentheses around the entire equation. If you don't like that, you can write, and maybe I'm going to squeak that in. Maybe people like that better. Going ahead and showing that I'm doing the same thing to both sides. It can be easy to lose track of your equal sign, so I think I'm going to write it like this from here on out. Using my distributive property, x squared times 1 over x squared is just 1, minus x squared times 1. In fact, let me not simplify this along the way. let's put in, what I wrote was not wrong, but I want to write in a little intermediate step. We're multiplying our fractions straight across. X squared times 1 over x squared is x squared over x squared. Minus x squared times 1 is x squared, all over 1 times x, which is x. And x squared times 9 divided by 1 is just 9x squared. So like we've been doing on all of these, clearing our decimals, clearing our fractions. By multiplying both sides by the least common multiple of the denominators that we have there, makes my life simpler. X squared over x squared is just a big fancy 1. X squared over x is just an x. All right. And now I'm going to go ahead and leave this to you here. You know your next step is setting this equal to 0. And either using the quadratic formula if that's what's required, or factoring if it's doable. Now there is no side to an equation, so I will say this. You have the choice of subtracting 9x from both sides, or subtracting 1 and then adding x to both sides. It's just, do you want to have that 9 be positive or negative? You're going to get the exact same answer either way. Okay? Now, before I jump into 9, just because I did mention something when I've been using my blue for clearing my fractions, and I've always just put the parentheses around the entire equation. And I was thinking, oh, I didn't do it here though, I did it on both sides. But I was just thinking, yeah, like see right here, I think that this would look nicer to some of us, so I'm going to sneak that in there. Multiplying both sides by 24. The notation that I used isn't wrong, but this just reads a little cleaner for some of us to see that it's a legal move. What I do to one side, I do to the other. And I think it's on that and then the very first one where we're just doing the setup, multiplying both sides by 100. 100 times 0 is still 0. That just looks a little bit cleaner for some of us. Okay? Sorry for backtracking, but I just realized that might have been a little bit of a sticking point for a few of you guys, which is understandable. Let's set up 9 together. Oh my goodness, it was still playing this whole time while I'm so sorry, you guys. I'm so sorry. On the other screen, I have, oh man, now I feel really bad. On the other screen, I have the homework, and it was dropping. My connection wasn't coming through, and so I wasn't seeing it, and now we're seeing it. I deeply apologize. I was just trying to look up problem number 9. Okay, let's do 9 together. What do you think I'm going to do? I'm going to clear these fractions. Since we're almost 20 minutes into this video, I am not going to remake it, and we will work through this at a reasonable pace. Let's do it real quick. All right, so here's number 9, and I apologize again for failing to hit pause while I was looking up the problem. So you guessed it, just like on all the ones before for this setup, whether it's factoring or using the quadratic formula, dealing with these numbers, we can set it equal to 0, but dealing with these numbers as fractions makes my life harder. So I'm going to choose to clear these fractions by multiplying both sides by the least common multiple of these denominators. If I skip count by 3 and 9, the first multiple that they have in common is 9. So if I multiply both sides by 9, and if you want 9 is 9 over 1, you will clear these fractions. All right, and that is a 3 right there. Multiplying fractions straight across, 9 times 1 is 9. DD, division by my denominator, 9 divided by 3 is 3. Doing a little bit of simplifying along the way. You can squeeze in a step there if you need to. 9 times 4/9 of x is 9 times 4 divided by 9, which is just 4 times x, which is 4x. And then 9 times minus a third is minus 9/3. DD, division by my denominator, minus 9 divided by 3 is minus 3. And so now you're going to go ahead and set this guy equal to 0. And try to factor if you can, if that's your strategy. And if you're not able to factor, you're going to use your quadratic formula. All right, so this concludes our video of the setup for questions 5 through 9. On all of these problems, my strategy was to go ahead and multiply both sides by a number that's large enough to clear all my decimals or to clear all my fractions, whether in this case here my fractions were all numbers, and then here we had one example like in 8 where my fractions had x's in the denominator. It's still the same strategy. We're multiplying both sides by that least common multiple to clear those fractions. The only other strategy that I had in here that is entirely optional is when we are given letters that are like A, B, or C. I think it's useful to replace them with X simply because the quadratic formula has A, B, and C in them. All right. Thank you guys so much. And again, I'm sorry for the big long pause before me doing number 9 while I was looking that problem up on the other screen.